We live in a world surrounded by electronics. From the moment we wake up to the time we go to bed, we are constantly interacting with various electronic devices. Our phones, computers, even our cars rely on intricate circuits and delicate components. These devices have become integral to our daily lives, helping us stay connected, informed, and entertained. But what happens when these electronics face an invisible threat, an EMP? Imagine a world where all your devices suddenly stop working, leaving you disconnected and in the dark. An EMP, or electromagnetic pulse, is a burst of electromagnetic energy. This powerful surge can disrupt or even destroy electronic circuits in an instant. It can be caused by a natural event like a solar flare or a man-made event such as a nuclear explosion. Both scenarios can have devastating effects on our electronic infrastructure. This pulse can disrupt or even fry electronic circuits, rendering our precious devices useless. Imagine the chaos and inconvenience of losing access to your phone, computer, or car. That's where Faraday cages come in. Named after the scientist Michael Faraday, these enclosures are designed to protect electronics from electromagnetic interference. These simple yet effective enclosures act as shields against EMPs. By creating a conductive shell, they prevent electromagnetic energy from penetrating and damaging the devices inside. They redirect the electromagnetic energy around the protected space, keeping your electronics safe and sound. This redirection ensures that the devices inside remain functional even during an EMP event. Think of it like a raincoat for your gadgets, keeping them dry in a storm of electromagnetic energy. Just as a raincoat shields you from rain, a Faraday cage shields your electronics from EMPs. In today's world, having a Faraday cage isn't just a cool science experiment, it's a smart preparedness measure. It's about being ready for unexpected events that could disrupt our electronic-dependent lives. It's about ensuring that you're not left in the dark when the grid goes down, that you have a plan in place to keep your essential devices operational, that you can still connect with loved ones, maintaining communication even when traditional networks fail, and that you have access to vital information. In an emergency, staying informed can make all the difference. Faraday cages help ensure that your lifeline to the world remains intact. Don't let the science scare you. Understanding the basics can be quite empowering. Faraday cages are based on a simple principle. Imagine a metal box. This box can be made from various metals, each with unique properties. When an electromagnetic wave hits this box, the conductive metal interacts with the wave. The interaction is crucial for the cage's effectiveness. Instead of passing through, the wave's energy is distributed around the surface of the box. This distribution prevents the wave from penetrating inside. The inside of the box remains a safe zone, protected from the electromagnetic energy. This is why sensitive electronics are often stored in Faraday cages. Think of it like water flowing around a rock in a stream. The water, representing the electromagnetic waves, flows around the rock without disturbing the area behind it. The rock, like the Faraday cage, redirects the flow, keeping the area behind it calm. This analogy helps visualize how the cage protects its contents. The material of your Faraday cage matters. Different metals offer varying levels of protection. Metal, with its abundance of free electrons, is an excellent conductor and therefore ideal for creating a Faraday cage. These free electrons help in redistributing the electromagnetic energy. The thicker the metal, the better the protection. Thicker materials provide a more robust barrier against electromagnetic interference. The key takeaway? A Faraday cage effectively creates a barrier, shielding anything inside from the damaging effects of electromagnetic pulses. This makes it invaluable in protecting sensitive equipment. It's a simple concept with potentially life-changing implications. Understanding how it works can help you better protect your valuable electronics. You don't need to be an engineer or spend a fortune to build a Faraday cage. There's a lot of misinformation floating around, making it seem more complicated than it is. Forget about expensive materials, complex grounding systems, or elaborate designs. You can build a perfectly effective Faraday cage using common household items. A metal trash can, a steel ammo box, or even a sturdy metal toolbox can all be transformed into Faraday cages. The key is ensuring a continuous conductive layer around the object you want to protect. Avoid any gaps or openings in your Faraday cage, as these can allow electromagnetic energy to penetrate. Remember, simplicity is key. A well-built, basic Faraday cage is far more effective than a complex design with flaws. Building a Faraday cage is like tackling any good project. You need the right tools for the job. Luckily, the materials are probably sitting in your garage or easily found at your local hardware store. First, you'll need a container. Look for something made of metal, aluminum, steel, copper. Think metal trash cans, ammo boxes, toolboxes, or even old microwave ovens. Remove the electronic components. Next, you'll need insulation. This prevents your electronics from touching the metal of the cage, which could create a path for the EMP to enter. Thick plastic bags, cardboard boxes, or even old blankets can work. To seal your cage, you can use duct tape, aluminum foil tape, or even just a tight-fitting lid. Don't overthink it. The goal is to create a completely enclosed, conductive shield around your electronics. Building your Faraday cage. A step-by-step guide. Let's get our hands dirty and build a Faraday cage. We'll start with a simple design using a metal trash can. First, clean the inside of the trash can thoroughly. Any dirt, debris, or rust could compromise the conductivity of the cage. Next, line the bottom of the trash can with your chosen insulation material. Now, place your electronics inside the trash can, ensuring they are well insulated and not touching each other or the metal sides. It's like packing for a delicate move. You want everything secure and protected. Once your electronics are inside, place the lid securely on the trash can. Use duct tape or foil tape to seal any gaps or openings. Remember, the key is creating a complete and unbroken Faraday shield. Congratulations, you've just built your first Faraday cage. Insulating your devices, an essential step for maximum protection. Here's the thing about Faraday cages. It's not enough to just throw your electronics inside a metal box. You need to make sure they're properly insulated. Think of the insulation as a bodyguard for your devices, preventing any sneaky electromagnetic pulses from getting too close. Wrap each device individually in a non-conductive material. Good options include bubble wrap, foam padding, or even layers of thick cloth. Avoid using materials that conduct electricity, like aluminum foil. You want to create a barrier between your electronics and the metal of the cage. Don't skimp on the insulation. It's a crucial step in ensuring the effectiveness of your Faraday cage. Grounding your Faraday cage. When and how to do it. Grounding is a crucial step in ensuring the effectiveness of your Faraday cage, but it can be a bit tricky to understand, so let's break it down. Now let's talk about grounding. Grounding is essentially connecting your Faraday cage to the earth, which helps in safely dissipating any unwanted electromagnetic energy. This is where things can get a little more technical, but don't worry, we'll keep it simple. Think of grounding as a safety valve for your Faraday cage, allowing excess energy to escape harmlessly into the ground. Grounding your Faraday cage can provide an extra layer of protection by diverting any residual electromagnetic energy away from the cage and into the ground. This is particularly useful in environments with high levels of electromagnetic interference. But here's the kicker: for smaller Faraday cages, like the ones we've been building, grounding might not be absolutely necessary. These smaller cages often have enough inherent conductivity to handle residual energy on their own. If you're using a small, completely sealed metal container, the conductivity of the metal itself might be enough to dissipate any residual energy. This means you can skip the grounding step if your container is well sealed and made of a conductive material. However, if you're building a larger Faraday cage or using a container with multiple openings, grounding is a good idea. Larger cages or those with gaps can benefit significantly from grounding to ensure all unwanted energy is safely diverted. To ground your Faraday cage, you'll need a grounding wire, which is typically a thick copper wire with an alligator clip on one end. This wire will act as the conduit for the excess energy to travel safely into the ground. Attach the clip to a metal part of your cage and the other end to a grounding rod driven into the ground. The grounding rod should be placed deep enough to ensure a solid connection with the earth. While grounding can be beneficial, it's not a substitute for a well-built and properly sealed Faraday cage. A good Faraday cage should be your first line of defense, with grounding as an additional safety measure. What to put in your Faraday cage. Protecting your essential electronics. Now that your Faraday cage is built, it's time to decide what treasures you want to protect. Think about the electronics you rely on most. Your smartphone for communication and information access. Your laptop for work and entertainment. Don't forget about other essential devices like a weather radio to stay informed, a flashlight for when the lights go out, and a hand crank charger to keep your devices powered up. A Faraday cage is like an insurance policy for your electronics. It's better to have it and not need it than to need it and not have it. So choose wisely and protect what matters most. Beyond the Faraday cage, additional EMP preparedness tips. Building a Faraday cage is a great step towards EMP preparedness, but it's not the only thing you should consider. Think about other aspects of your life that could be affected by an EMP event. Have a plan for alternative power sources like solar panels or a generator. Stock up on non-electronic essentials like candles, matches, and a hand crank weather radio. Create a communication plan with your loved ones in case phone lines are down. EMP preparedness is about more than just protecting your electronics. It's about being prepared for anything and ensuring your ability to thrive in any situation.